So, gravity. Quite an incredible thing, right? From simply seeing gravity as the force that makes an apple drop down, to using it as a way to find out how global warming is going with the sea levels. Hi, it's me, Jarrell Aldawich, and I want to discuss how gravity can affect and display global warming. So, first, what is global warming and gravity? Global warming is the gradual increase in the overall temperature of the Earth's atmosphere and is generally attributed to the greenhouse effect, which is caused by the increased levels of carbon dioxide, CFCs, and other pollutants. This process could eventually cause the melting of the sea caps, which would lead to the rising of the sea levels, which would drown and kill us all. So that sounds fun. Rising sea levels are the result of the added water in the hydrosphere from the melting of land ice and the expansion of seawater as it warms due to global warming. Sea levels have risen immensely by about 20.32 centimeters since the records kept track in 1880. It has been predicted that it will rise another 30.48 centimeters to 1.22 meters by 2100. That isn't good. What about gravity? Gravity is the force that attracts our body towards the center of the Earth, or towards any other physical body having mass. So it stops us from floating off into space. Now, with gravity, the best way to find the force of gravity between two objects is to use Newton's law of universal gravitation. Within this law, the formula F equals G m1 times m2 over r squared was born, and it is used to determine the force of gravity between two objects. Within this formula, F stands for force in newtons, G stands for the universal gravitational constant, and this is, within this formula, 6.67 times 10 to the power of negative 11, and R stands for the distance between the two centers of the two objects, and M1 or M2 stands for the mass of each object. An analogy to explain this is to say that gravity is like love in a family. The more family you have that is together, the more love you feel. If one family member gives you a hug, you feel love. But if you bring in another family member, and another, you get a much bigger hug and feel more love since the family members are incredibly close to you. Within this analogy, love symbolizes gravity, and each family member represents mass, and their closeness to you represents the distance between the two centers of mass. Basically, this analogy means that the more mass you have around you and the closer it is to you, the more gravity you feel. So, the best way to learn this formula that proves this analogy and Newton's law of gravitation is actually to apply it to a question. So, here is a good starter question we can work on. Calculate the gravitational force between you and another person, both the mass of 60 kilograms and both of you are 5 meters apart. So first, to find out this question and put all the values into the formula, we will first have to find the G, which stands for gravitational constant. And we know this is equal to 6.67 times 10 to the power of negative 11. Since we have our G, we need to find our M1 and M2, which is the mass of each object. And from the question, we know that both of you equal 60 kilograms. And lastly, we have to find R, which is the distance between the two centers of the two objects. And we know from the question is equal to 5 meters since the masses are 5 meters apart. But we need to square this value for the formula. So once we place it into the formula, make sure you square it. Now that we know all our values, we simply have to place it into the formula seen here. After we do this, we end up with 6.67 times 10 to the power of negative 11 times 60 times 60 over 5 to the power of 2. This then equates to 0.0000000096 newtons of gravitational force between these two people. Even though this number is so small, it's due to the small masses and the distance between them. Now let's talk about a very common misconception that ruins people's concept of physics and their ability to calculate anything including gravity. This is the misunderstanding between the words weight and mass. Now in physics, weight is defined as the force exerted on a body by gravity, while mass is defined as the amount of matter within an object. Due to the colloquial language implemented in our daily life, weight is often regarded as the same thing as mass. Weight is believed to be about heaviness and how much matter is in an object, and people have replaced the meaning of mass for the meaning of weight. People have completely forgotten about mass and the difference between mass and weight. This is completely understandable as our everyday language and the language of those around us influence our understanding of anything, but this does not change the fact that this is a misconception and is completely wrong and can sabotage anyone's work into physics. as they start to replace weight for mass and mass for weight, though they are two completely different things. Now that we've learned how to find the force of gravity between two objects, how can this display any significance towards global warming and rising sea levels? So basically, a rise in sea levels will cause a rise in the mass of the Earth. This is due to the increase of water in our hydrosphere. This increase in mass affects the Earth's usual gravity between the other planets in the universe, since mass is a major component in the formula for finding gravity between two objects. This means that gravity is affected due to the rising surface levels. Now let's talk about the strength of gravity. On every surface of the Earth, gravity is felt, and different factors affect how strong a gravitational field strength is. But what are the factors that affect gravitational field strength? The formula that demonstrates gravitational field strength is shown here, and is G equals gm over r squared. This formula has one component that is always set, depending on what planet we are on. As mentioned before, this component is G, which stands for gravitational constant. This constant on Earth is 6.67 times 10 to the power of negative 11 newtons. Due to the fact that G is a constant, it can't be a factor that affects gravitational field strength. So what is? In this formula, the r, which is the distance from the center of our Earth, and m, which is the mass of the object, can change depending on what object has been chosen. So due to the changing distance and mass, these factors are what affect the strength of gravitational forces. An example of the use of gravitational field strength formula and the factors that affect it is if we find the gravitational field strength on the surface of our planet. So to first find this, we need our mass, distance from the center of the Earth, and our gravitational constant. We know our gravitational constant, which is 6.67 times 10 to the power of negative 11. And we know our mass of the Earth with a simple Google search, which is 5.972 times 10 to the power of 24 kilograms. And to find our r, the distance from the center of the Earth, we are simply going to have to find our radius of the Earth, since our radius is the distance from the center to the surface, which is exactly what we are trying to find. So r is going to be equal to 6.38 times 10 to the power of 6 meters, which is our radius. Once you enter all these values into the formula seen here, like what is shown, you should get the value of approximately 9.8 newtons of force per kilogram. This is the strength of force that works on us every day. An example of this force in effect is simply us staying on Earth without floating off into space, or an apple falling off a tree, or simply when you drop something and it falls to the floor. This 9.8 newtons works on us every day for our entire lives upon this Earth. So now that we know that mass and radius are the factors that affect gravitational field strength, this proves that the gravitational field strength will differ between our Earth at the moment and our future Earth with the rising sea levels. This is due to the fact that the rising sea levels will cause a longer radius and more mass for the Earth, since it extends the Earth in these aspects. Since radius and mass are two factors that affect gravitational field strength, if any changes are done to them on our Earth or in anything really, gravitational field strength would change. Gravity has thousands of different aspects towards it. It could explain a range of subjects and can show the effect of different processes on Earth. In this case, the rise of sea levels is having severe effects on gravity on Earth. But the process of rising sea levels is slow, so the effect on gravity is quite small at the moment. But one day, we never know, the sea levels could rise so high that boom, gravity could change immensely, having all kinds of repercussions. But this would only happen in thousands of years in the future. Quite a long way away. So what about you take what you learnt here and go enjoy life? This is Joelle Al Darwish, and I'm out.